everybody. Welcome back. We have something to talk about here today that whether you know it or not, it's affecting you. That's a guarantee because everybody here eats. And if you're eating, you are being exposed to certain toxins, a change in the reality of food supply and agriculture, uh, a change in chronic disease levels that we're all seeing. We can't answer why they're happening. Well, we're going to get into answers today. Brendan, thanks for joining us.
My pleasure. Thanks for having me.
So Brendan Moorehead has been diving deep into this topic, and I've been excited about this conversation in terms of toxins in our food supply. So thank you for bringing this forward to us because every single person needs to know this.
I had the opportunity to interview Dr. Joseph Pizzorno a few years ago, and he's been a naturopathic doctor for, I believe, over 40 years. He founded the Bastyr University up in Washington State. In recent years, he's been saying, like, his main message is, as far as he can tell from reviewing the literature on many diseases, the primary cause of disease is mitochondrial dysfunction rather, caused by toxins from our environment and our food, but primarily from food and water. So, which of course is our environment, but so food is a big part of it. And shockingly, actually, organic food is not entirely exempt from exposure to some of these toxins. And there's a couple for that I can get into in a minute, but yeah, go ahead.
Yeah, and that was surprising to see because it's so prevalent that, I mean, you really don't know where to go anymore and what's safe and what's not safe. Like you openly say that even organic foods, there's certain things you have to look out for.
Yeah, so the problem with, and I want to say first, organic is far better in general than conventional food as far as exposure. But we have this small molecule called glyphosate. It's very, very, very mobile. It's in rainwater, and it's 65 or 75% of rainwater in the United States. So that's getting to everything. It's also in the water, in the irrigation ditches. So it's going from one farm to another. They also spray herbicides like glyphosate on the ditch channels to control weeds, as if the weeds are really a problem there. And so that's poisoning the irrigation water. And then you have the issue. This is going to be perhaps an eye opener for some people, but organic farms can use manure from animals. Right. That manure does not have to be from organically raised animals. It can be conventionally raised animals. So everything that's going in the mouth of those animals and coming out the other end is going onto organic farms. That includes a lot of conventionally raised grains, and those grains are drenched in glyphosate and atrazine, which is another herbicide, and which damages complexes 1, 2, 3, and 5 of the mitochondria. The other thing about what goes on to conventional crops that ends up in, drumroll please, sewage sludge. So sewage sludge is allowed to be applied as fertilizer to conventional crops, and it's called biosolids. That's kind of the euphemism for it. And the thing about biosolids is there's a lot of heavy metals going into biosolids from just municipal water supplies, industrial, basically everything gets flushed down the toilet, and many things that come out the tailpipe of industry goes into municipal water supplies and ends up in sewage sludge / biosolids. And the EPA has come up with a concept that they call sludge magic. And that sludge magic is the idea, the magical thinking that the organic matter poop of the organic matter in sewage solids, biosolids, binds irreversibly and immobilizes irreversibly all the heavy metals that are there.
Oh, wow.
Right. So arsenic, lead, cadmium, mercury, I think maybe thallium, I'm not sure. But those are those top four, the arsenic, lead, cadmium, and mercury, pretty high in sewage and biosolids. So that's going in and contaminating the conventional soils. And by the way, conventional soils get a lot of cadmium as well, because when I say conventional soils or conventionally grown food, I just mean mainstream chemical, highly mechanized, industrialized agriculture. So the phosphate fertilizers that are mined, so the ore often contains a good deal of cadmium. So cadmium comes along for the ride to the non-organic, the conventional farms of the world. And so you get a higher amount of cadmium in the soil. And legumes, in particular soy, preferentially absorb a lot of cadmium.
Oh man.
So women with osteoporosis actually have been found to have been eating, typically they have a lot of cadmium in their kidneys, 16-year half-life in the kidneys for cadmium, and it damages the ability of the body to convert 25-OH vitamin D to 1,25-OH vitamin D, which is the calcitriol, however you pronounce it, version that is actually the ultimately the active form that is used to manage calcium. So women with osteoporosis very often tend to be high soy consumers. And that's the mechanism there. So back to sludge magic. That's how the heavy metals via phosphate fertilizer and biosolids are getting into organic food via the gastrointestinal tract of conventionally raised cattle and manure.
That is so mind-blowing.
And then
because,
so then organic non-GMO soy is going to be potentially high in cadmium, because that there's going to be some higher cadmium in organic soils that are using manure.
Honestly, my brain is a little fried right now because it's turning into sludge, because there's so, when you think about it, how do you escape all that? It's like so prolific.
Go to Mars. That's the solution. Just throw this planet aside and go to Mars. They don't have an atmosphere there or water, but we'll get by. Yeah. So how do you get around this? So are we going straight to biohacking?
Why not, man? Everybody's jaw's probably already dropped, and now it's like, what do we do about this?
Heavy metals is it's actually quite a trick to get heavy metals out of the body. And you don't just want to attack it with DMPS and MSA. And there's these chelation clinics that they'll just attack with that, and it can really mess people up because they may not be ready for that. Some people can handle it just fine, but a lot of it has to do with the relative efficiency of their detoxification enzymes, which of course a company can help shed light on, as far as like which SNPs you have and which of the GST, the based enzymes that conjugate glutathione in phase 2 liver detoxification. Right. And, so those transferase enzymes. And but if we're going to look at it at going after heavy metals, you have to go all the way back and say, how inflamed is the person? Because if the person is really inflamed, they're going to be really sensitive, and they may react to just about anything. If you're mobilizing metals, they can react to even good NRF2 promoters, like some kind of cruciferous vegetable extract. They can get inflamed from that because it's just moving things too fast. So you have to deal with their inflammation. So one of the things that's actually kind of cutting edge, a lot of practitioners are starting to use, I don't know if a lot is the right word, but at least the ones I'm following are starting to use peptides. BBC, KPV are 2 oral peptides you can take orally, you don't have to inject. And then there's others, TB-Frag 17 and stuff that are anti-inflammatory and can help calm down the neuroimmune activation that has been generated by Lyme disease or just dysbiosis. If somebody has really bad, really imbalanced gut bacteria, and then they have intestinal inflammation, which is, by the way, aided and abetted by glyphosate, because glyphosate is an antimicrobial that disproportionately kills beneficial bacteria more than dysbiotic bacteria like Klebsiella pneumoniae. Now, that organism and others may be more prone to producing more beta-glucuronidase, which undoes your liver's handiwork by deconjugating the toxins that have been conjugated by the glucuronidase step. Anyway, the glucuronidation, the UDT enzymes, and those toxins tend to be the fat-soluble toxins like mycotoxins. So if somebody has mold toxicity, which is pretty common, then that can be deconjugated in the gut and then reabsorbed. So glyphosate is doing that. It's causing dysbiosis, and if it's causing dysbiosis, and if it's causing intestinal permeability, which dysbiosis does by itself, but also glyphosate upregulates zonulin, which is a signaling molecule that tells the tight junctions in the gut to open, and it's done judiciously when the body is normally regulated. So just judiciously samples what's in the gut. But if you have glyphosate upregulating it a lot, they just stay open and stuff comes through, and there's more lipopolysaccharide from the exterior of gram-negative bacteria, and that is very inflammatory to the liver. So the liver is inflamed, and then one of the things that happens in that is some of the membrane transporter proteins in the hepatocyte membranes, where they're transporting bile, conjugated toxins, and phosphatidylcholine into the biliary canaliculi, which is like the headwaters of the whole biliary tree that drains down into the gallbladder. Those membrane proteins under inflammatory conditions can retract inside the cell, and then toxins are not getting out. So as phase 2 conjugates are backing up, and then phase 1 activated intermediates are backing up, and that's where like the cytochrome P450 enzymes in phase 1 are typically oxidizing something and making it temporarily more toxic but more reactive, so it can conjugate more easily in phase 2. Phase 1 intermediates back up, that's really damaging to the hepatocyte, and eventually to save itself it push it back in the bloodstream, because as we all know, dilution is the solution to pollution. Even the liver knows that, right?
Yeah.
No, but that's what happens, whether it's in society or in the liver. When you're in a crisis state, you're just like, well, just dilute it for now.
Yeah.
So anyway, so now this stuff's in the bloodstream, and guess what? Glyphosate makes the blood-brain barrier also more permeable, and it preferentially helps aluminum and certain other toxins get into the brain, but aluminum in particular and cadmium get into the kidney cells. So basically, glyphosate's making things more permeable, making everything absorb more toxins, and it's also indirectly causing, and pretty directly too, causing the liver to have this breakdown in function, because one of the cytochrome P450 enzymes, don't ask me the number right now, I don't try to memorize these things, I just know they're there and I can look them up, but it's one that makes bile acids. So glyphosate directly impairs bile acid production. It's also directly impeding certain cytochrome P450 enzymes that are involved with, among other things, beginning the biotransformation process of estrogens and getting them out of the body, because the body, like estrogen is in cycles, especially in women, because there's a period when the female body needs growth signals. Estrogen is essentially a growth signal, and then it needs to come back down. So it's just this pulsatile wave. So female body needs to get rid of estrogen in a timely manner. But when you have glyphosate in the picture, that's not going to happen.
Yeah.
Or it's going to get, or the pathways are going to get deranged, and you have more of the estrogens getting converted to the more toxic metabolites, like the 4 and the 16.
Right.
So and then COMT has to come in, catechol O-methyltransferase, and that's the phase 2 part of handling those. Glucuronidation can be involved as well with estrogens, but the COMT part comes in, and then if you have a bad COMT enzyme, a slow COMT enzyme, and or if you have methylation issues, which would affect the supply of S-adenosylmethionine, SAMe, which COMT uses to methylate these things, then you've got double, triple trouble.
Yeah. You know what's incredible, everyone has to appreciate what they were just given access to, because I think everybody agrees that people are sicker now because of our food, right? And there's a lot of people still arguing that maybe that's not true, that environmental health is not a concern. But what we don't hear, we hear the genetics of it, that there's certain detox pathways, glutathione, glucuronidation, the methylation pathways, all these things that support or don't support what we're facing. What we don't hear, what you just laid out, the exact insults, like exactly what is happening step by step. And the way you just laid it out, it's undeniable. Like, here's exactly what's happening, and here's why it's a problem, right? And that's what everybody needed to hear, I believe, because there's always a little bit of gray area in environmental health. Why does it make me sick? I think one of the areas where there's still controversy where there shouldn't be, and I think because of the sort of incentives or needs to make sure that we don't all know the truth, is with early childhood development with children, and that's where the word glyphosate really gets used the most, right? In terms of functional medicine, etc. So, what have you seen in practice in terms of you know the current child growing up today? Is the child different? Are
Oh,
outcomes different? Is there a giant change in what's happening in sort of environmental health versus their outcomes?
well, I'm probably not the best person to ask that in terms of my practice because I have not been working with children. But
Okay,
I do know that. So, for example, back to Dr. Pizzorno,
sure.
quoting from the research, anybody can pretty much look this up as well. But the organophosphate pesticides, they've done research on the children of mothers that had some, everybody has some level of organophosphate pesticides. The children born to mothers with the highest level, I think they were using quintiles, so the women with the highest, in the highest quintile of organophosphate pesticides in their body, compared to the women in the lowest quintile of organophosphate pesticides in their
Mm-hmm.
body. The difference between those two cohorts, or those two groups, was a 7-point difference in IQ in the kids,
Wow.
children of those two mothers. So organophosphate pesticide has a big impact on the children's IQ, and 7 points is a big difference.
Yeah.
People that I don't know how they come up with this estimate, but estimate that that's essentially equivalent of a kid working hard and getting straight A's and a kid working hard and getting C's.
Mm.
So the difference in the prospects in life for those two
Yeah.
children vastly different. It's beyond tragic. And there's also been a study. Also, I've obviously I get all of my examples from Dr. Pizzorno. Just kidding. I'm on a tear with him right now. So there was research done in I think Seattle, Washington, where they had children that were eating non-organic, and they were eating like 75% conventional, I think it was, and they went to 75% organic or something like that, or maybe it was 100. I'm not sure. Maybe it was 90. But anyway, they made a big shift from away from conventional toward organic, and in 30 days, the quantity of pesticide in their body dramatically plummeted. So, assuming we're dealing with kids that have reasonably good genes and stuff, because obviously there are some kids that are pathological detoxifiers. Kids with autism have messed up detoxification. So that kind of rapid shift may or may not occur.
Yeah.
It may not happen as fast in autistic kids, but there's actually a documentary called Secret Ingredients, that Jeffrey M. Smith created, of the Institute for Responsible Technology. So in that movie, they focus on one family, and they had an autistic child, and the mother and father also had some health issues. And just by going organic, their health issues resolved. They probably did a few other things that I'm not recalling, but that was one of the main things that they credited for their son becoming, I think he was basically no longer diagnosable as autistic by the time it was like 11 or something, and it'd been about a 5-year period. So it was a delightful
That's
result.
incredible. And this is coming from a place where the belief is it's not reversible. It's something that you have, right? It's a condition versus your body reacting to poor choices. And poor choice is not necessarily the fault of the parent. You're doing what everybody else is doing, but your child may not be wired for those things, right?
I would say we have to be really sensitive on the topic of autism, because first of all, I don't want to be interpreted to say that all you have to do is go organic, and it's that
Right.
simple. It's not that simple most of the time. And it's also not just a matter of, I would say, of choices. Although if it's diet, then yeah, that's choices. But there's typically other factors involved with autism, and the genetic analysis is super important. But they're also discovering that there's, depending on who you listen to, like this group of autistic children, my God, 80+% or whatever had Lyme pathogens, and then this other study is like, oh my God, the glyphosate levels were astronomical, or, oh my God, all of these kids, they went autistic within 3 weeks of this particular vaccination.
Yeah.
Just all these factors that seem to have, but so it's kind of like, any disease can be caused, almost any disease can be caused by almost any toxic insult to the body that dysregulates the body. So it's
Yeah.
not like there's one cause of autism, but if there's one, the one that correlates the highest is glyphosate.
Right.
It's crazy. It's it's as close to a correlation coefficient of 1 as you can get. I haven't seen anything higher. It's 99.7 or something like that. If you look at the graph for when glyphosate use started to really escalate in the, I think it was mid 80s or not mid 80s.
Right.
I think it was it was either 86 or 96, and I don't know why I can never remember that one. But you look at it, they both just start to take off right at that point. Glyphosate and autism. And the thing about glyphosate is, and the other thing about about autism is they find a lot of aluminum in the brain, and a lot of but aluminum. So there's the hypothesis. Well, there's a lot more aluminum in the next generation, or the like of vaccines when they got rid of the mercury part.
Right.
That's another story. They didn't really fully get rid of the mercury part, but it's not on the label anymore. And then they started using aluminum as the official adjuvant, and glyphosate transports aluminum into the brain. Glyphosate transports all kinds of things into the brain because it makes the blood-brain barrier leaky. That's probably, if glyphosate is like the main cause, it's because of that mechanism. And then whatever else can get into the brain, including Lyme pathogens or whatever, Lyme gets right into the brain with or without glyphosate, but glyphosate helped it get in there for sure.
Yeah. I think your point, people need to understand that everyone's looking for that cure, that switch to turn on or off. And this is why it's such a tricky subject and referred to as more of a spectrum than a condition, because so many things cause it. And what we need to look at is not the things, but the genetic profile of that child who couldn't cope with whatever happened to be the trigger. It just, if something came before that, whether it was Lyme, mold, glyphosate, whatever it was, the order it came in is the order that you're going to discover that it affected them. So it's really understanding your innate wiring capacity to deal with any toxic insult, and then knowing what all the potential insults are, right? And there's many of them. And this is why it's hard to point your finger on a cause. The cause is really that inability to deal with all of this stuff, all the things you're talking about. So one thing I wanted to ask you about is you did something incredible. You hosted a summit called Eat for Earth. And a lot of people are still buzzing about that, blown away. And you talked about how our food system is endangered, the planet is endangered. People drew a lot from that summit, and it really changed the way they think. Can we dive into some of the things that you uncovered there?
Yeah, sure. So in it, much of what I said just now from quoting from Dr. Pizzorno was part of two of it. I did 2 interviews with him.
Okay.
So he's in there, and those were great interviews. First one's a little bit grainy because the webcam on his laptop while I was traveling was an older one. I'm like, oh my God, this one's so grainy, but the content was great. What really blew me away, hands down, was getting to meet and talk to Walter Jena twice. Walter Jena is a scientist from Australia, and Australia has this Commonwealth Scientific and Industrial Research Organization. I think that's what CSIRO stands for.
Okay.
So he was both a soil scientist and a climate scientist, and very, very intelligent guy. But he's able to make things really clear and simple. And in our conversation, we talked about how when it comes to climate, water dominates the equation as far as heat retention by the planet.
Okay.
Water vapor is a far more powerful greenhouse gas than carbon dioxide, but the climate models were based on carbon dioxide because back when they started doing that after Carter wanted task force, I guess, to investigate. Anyway, so they basically made the assumption, well, hydrological cycles are too complex and massive for us to model. So we'll model carbon dioxide, and we'll assume that as carbon dioxide carbon dioxide's greenhouse effect is amplified. That'll then cause more water vapor, which will then amplify that cycle. But then they have to keep adjusting the model because it doesn't really work that well. So, but the real kicker is the greenhouse effect is only accounts for, I think it was, he said 4% of climate dynamics and energy flux, heat flux. So the rest of it is what? It's hydrological cycles. Not now, water vapor is a greenhouse gas, but water is acting also over here as in other ways. So you have the flux of energy up into the atmosphere via transpiration, which is the water that's moving up through plants and getting transpired into the atmosphere. So that's one way that water is moving, the heat is moving into the atmosphere. It's being carried by the water vapor. And yes, the water vapor behaves as a greenhouse gas. But how is that heat actually getting out away from the planet? Mainly via rain events that open up an aperture in the atmosphere of all the greenhouse gases. And I'm not sure if I'm explaining that part correctly, but during rain events, a bunch of heat escapes into the upper atmosphere and back out into space. So there's like this flux of heat from the earth back out into the atmosphere, and it depends on healthy soils, healthy plants, healthy ecosystems, transpiring water into the atmosphere, and then it depends on normal cycles of storms and so forth, opening those apertures in the atmosphere so heat can get out from the lower atmosphere into the upper atmosphere and back out into space. So that's basically it. And those hydrological cycles, he named about 10 of them. And I wish I could say I had memorized them, but I think I had them memorized a few years ago. Now I don't recall each one, but I gave you the gist. But and there are things that we're doing that are impairing that process. One of which is we're creating what he calls humid hazes, persistent humid hazes, and that's occurring via the dust that we're putting in the atmosphere by desertifying the planet. And also by burning things like forests and cane fields and grasslands. So we put a lot of particulate matter up there. And then diesel, we burn a lot of diesel. So that puts a lot of particulates up there. And that is creating these abnormal types of clouds, we could call them, the humid hazes, that don't rain. So then you have far fewer of these events, which in the tropics would happen like daily, right? If you've lived if you ever spent some time in the tropics, especially during the wet season for that particular tropical area, it's like every afternoon it rains, it cools down. So it heats up, it's building, it's getting humid, storm brews, you have that 4 o'clock rainstorm, cools off. That's not happening as much anymore. So they're having abnormal rain patterns, like deficiency of rain in tropical areas. And so that was like a big aha from Walter Jena, is realizing that how climate actually works is not what we've been told. And yes, there's a heat problem, and yes, there's a carbon dioxide problem, but actually, and this is coming from another one of the interviews, the carbon dioxide issue is less the greenhouse gas effect and more so the fact that the ocean absorbs a lot of this excess carbon dioxide, like the majority of it, and in water it turns into carbonic acid. So the oceans are acidifying, and if that happens faster than the organisms can take the carbonate and put it into shells and exoskeletons, which then drop to the bottom of the ocean as they die, if it's accumulating too fast, the carbonic acid, then the pH drops, acidity increases, and at a certain point, it's dissolving their exoskeletons and their shells. So already we're seeing that, like for example, pteropods, Pteropods, pteropods. So the pteropods, they're little tiny snails. They're a planktonic organism. They're like snails. They're the base of the food web in like Arctic type areas and like subarctic, like Pacific Northwest. So all the I think krill eat them. I'm not sure. That krill is kind of more of an equivalent organism. So small fish and then salmon are eating the small fish, and then the seals are eating the salmon. The orcas are eating the seals and the salmon. So that ecosystem is at risk if the pteropods dissolve, and their populations crash. Another one is the unfortunately I had horrible insomnia last night. Yesterday, and I'm a fast oxidizer, so my adrenaline just goes crazy when I'm hungry.
Yeah,
So anyway, these photosynthetic planktonic photosynthesizers that build like a little shell, an exoskeleton around them.
okay.
And those little exoskeletons are at risk of dissolving. I think some of them already are, and we've seen in some oceans of the world like a 40% phytoplankton. That's what they call them, phytoplankton. Phyto meaning they're like plants, and they photosynthesize. Plankton meaning they're planktonic things floating around in the ocean. So the phytoplankton, 40% drop. This was as of 2010. I have not seen anything reported since then. So I don't know if everything's like copacetic for the moment, or if they don't want to talk about it, because there are some scientists that are like, yeah, we're all dead. It's all over except for the shouting. And we've got until 2040 or 2050. I mean, that's what some scientists have said. And I hope they're wrong. And I tried to interview one of them. They wouldn't, like, there's a couple scientists, they just didn't want to talk to me. And I figured because they probably just don't want to ruin everybody's day because they're going to say something really negative. But hopefully that's not the reason they didn't say yes to the interview. But it might be very dire. So that was one of the things we talked about in the conference. But the other thing is, okay, so you've got these really horrible stories that, oh shit, things are happening that are really bad, and we didn't know about them. We didn't know about the phytoplankton, the pteropods, et cetera. The flip side is, and this is back to Walter Jena, we just have to regrow what he calls the soil carbon sponge. Soil is carbon. We can draw down all kinds of carbon from the atmosphere. He says we can, if we did the right thing on 1 billion hectares, which is about a fourth of the total agricultural land, including pastures. And a lot of this can be done in pastures. It's gonna be a lot harder to convert the thinking and the practices of farmers on arable land. But it's probably easier to get pastoralists to do their grazing differently. And there are ways of grazing animals that are profoundly beneficial to the soil compared to really bad grazing habits that just ruin the soil. So there's a good way and a bad way to do everything. Cows are not the enemy. It's management. Bad management is the enemy. So bottom line is we can rebuild the soil carbon sponge and the whole photosynthetic machine and the evapotranspiration machine that these technologies, let's say the planet had it all figured out, whether God did it or evolution, whatever, it all worked perfectly. And all we have to do is stop interfering and get the soils working better, because then we're actually going to have a cooler surface on the planet, and we're going to have a functioning heat flux back out into the atmosphere, and we can suck a lot of carbon dioxide back out of the atmosphere into the soils. I think what I was about to say is Walter Jena says, yes, we can draw down 20 gigatons of carbon every year. That's twice our net emissions.
Wow.
Carbon into the atmosphere. So this, if we could just get everybody focused on this, we could fix everything in a decade.
Oh, wow. And yet you're not hearing about this anywhere.
No, and we have this stupid distraction. One of the things I was going to say is, like, in terms of, like, to echo what Zorno said about toxins being the main cause of disease. And I think in the alternative world, we kind of know that, but it's like the rest of the mainstream is like, no, it doesn't matter what you eat. No, it just happens. Disease happens. We can't do anything about it, but we'll treat you. But anyway, so, the World Health Organization, which, has kind of lost much of their credibility recently, but they did some good research. They've done lots of good research over the years. And one of the things they concluded quite a few years ago is that toxins are like one of the main causes of disease. But anyway, now we have this other WHO-sponsored thing that's really distracting. So I think a lot of attention has been drained away from the planet.
That's mind-blowing. When you think about, all we hear is beef is bad. Beef is the source of all of our problems.
Worst message possible.
Yeah.
And it's just greed, because I don't think it's just stupidity. I think that that there's sort of an unholy alliance between the tech elite, because they, and just in general, investors,
Yeah.
It's the next frontier. Monsanto's been working, and others like it have been working on owning food.
Right.
The one thing they had not yet conquered, I mean, because they conquered a lot of crops and a lot of other things, they hadn't conquered animals.
Yeah.
Can we just make all of our meat in a factory using intellectual property that we own? Bingo, nice new industry, nice new frontier. Awesome.
Yeah, no kidding.
Really good for investors. That's what.
So when we talk about eat for Earth, at an individual level, anybody that's listening to what just happened here, I'm sure is, going to be compelled to say, well, what can I do? So how do you start? How do I eat for Earth? How do I do what I should be doing?
Yeah, just going a really long fast. Um, so the first step is, well, you could go organic. So that's like a baby step. So, for some people, that might be a big step. But next step or a parallel step would be get to know your farmer. They don't have to be organic if they're doing organic things. They don't have to be certified organic. So at farmers markets, you can try to gauge whether you trust what somebody's telling you and talk to them about how they grow things. And a lot of people say, yeah, we don't use this, we don't use that, we use a little bit of this. We're learning about regenerative agriculture. We're not certified organic yet. We might do that when it's a lot of money to get certification, whatever. So you can get some, feel that out. Now, there are some labels, some certifications that have been coming out the last few years that pertain to quote unquote regenerative agriculture. So what is that? So regenerative, there's differences of opinion there. And unfortunately, there's this divide where vegan and veganic movement that is very against using animals is very, and I think they have a point in being kind of concerned that regenerative agriculture tends to always claim that animals need to be part of the process. I think that animals are an important part of the process when it's appropriate, and there's a whole conversation there. But I also don't think that we should say that veganic agriculture is not regenerative because animals aren't involved. I think we need to have a more cohesive definition, more inclusive definition of regenerative agriculture. That does not say that one of the pillars of organic agriculture is that you use animals and you use their manure. But it's a great, as long as you're not putting, conventionally raised crops through those animals, biosolids, heavy metals and stuff, then it's great to use animals. And I won't get, unless we really want to, I won't get into like why animals are so amazing for soil fertility. But organic agriculture generally has to do with, regenerative agriculture generally has diversity. So you use diversity, you don't do monocropping. You have a lot of plants because that creates a lot of diversity in the soil organisms, and you just get better, healthier soils. The other thing you do is you keep the ground covered at all times. In non-regenerative agriculture, both conventional and organic, they're constantly clearing all the crop off, all the crop waste, the stubble, and they're just leaving this open soil to oxidize and put carbon dioxide into the atmosphere,
right?
Kill the soil organisms. So whatever you gained in that growing season in soil life, you then kill it with the sun and the desiccation and erosion and whatever. So you got to keep the soil covered. It's funny, I haven't even looked at the 4 principles. They're like 4 main principles. I haven't looked at them in a while. So keep the soil covered. You got diversity. Typically, they include animal impact and so forth.
Okay, because I think it's important to point that out, because the very beginning, what you said is that we're currently in a state where our poor mitochondrial function is causing all this disease, right? And a lot of that has to do with food. So we're focused on fixing our food. So you just finished telling us some things we can do to eat better, but it's so difficult to get things right when it comes to food, especially with what's being offered, and who knows what it's going to look like in a few years with all the forces that you're talking about that are trying to make changes, right? So you also have to work on the other half, that assume that you're not getting the best, and then what can you do to support the damage being caused, like what you're doing right behind you, right?
Yeah, so let's get into more of that. So I was talking about, how can you source better? How can you
Sure.
source your food better? So like, how do you get these things out of your body, the toxins that you've accumulated? And, part of it is also, the other part of the equation with conventional food, and also to a degree with organic food, is that the mineral nutrient density is not what it was.
Mm.
So there's a graph that was created by a guy named August Dunning, PhD, and it's out there on the internet on SlideShare. If you Google his name and you look for Eco Organics, it's the name of a company that he had, he was telling the story of nutrient depletion. And he shows that from early in the 20th century to, I think, year 2000, there was basically in some minerals an 85% decline. But if you look at some of the reports you can find on the internet, they just look at like 70s to 90s or 50s to 70s or whatever. The USDA doesn't seem to make it easy to find the data that he found, because if you look at that broad swath of time, you'll see a dramatic drop, and it correlates with the increase in mechanization, where they start chopping up the soil more intensively with tractors and stuff, and and then applying the first wave of fertilizers, and then the first wave of pesticides. All these things had damaging effects on the soil's ability to deliver micronutrients. So why is that important? Because at the foundation, this is not the only factor in metabolism, but we are enzyme machines, and that is a term I'm borrowing from Dr. Pizzorno. And so enzymes often require a cofactor, and often that cofactor is a mineral. So if we're short on minerals, and glyphosate chelates minerals, it's patented as a chelator. In particular, it really goes after manganese and iron and cobalt and molybdenum, and there's actually a lot of minerals that goes after, that just binds to them. So we need these minerals to run our detoxification enzymes. In particular, selenium's pretty important. Manganese, well, let's see, yeah, manganese for certain antioxidant enzymes, and of course there's B vitamins. That's easier to get, from food. It's not as depleted in food, but so you want to make sure that you test your minerals and your vitamins and your toxic burden to see where you're at. I would say that's like a first step, is people should know where they're at, and of course look at their genes, because if you have disadvantageous genetic variants, you may be where the enzyme's a little bit inefficient, and sometimes that inefficiency is its inefficiency at binding to its cofactor. So maybe if you can supply a cofactor, but that depends on whether it's a vitamin or a mineral. You don't want to oversupply certain things. But you can kind of oversupply riboflavin safely, and that's going to help support MTHFR. That's going to support that's the methylation of folate. Support GSR, which is recycling glutathione, because that requires riboflavin. So there's a lot of there's certain practitioners that have been for decades just giving people a ton of riboflavin. So like Frank Schallenberger in Carson City, Nevada, he's big on just giving people a lot of riboflavin. A few other things he does, of course, but that's just like one thing. I thought that's really smart, because if you look at riboflavin, it's pervasive as far as what it's used for. It's so important to mitochondrial function, energy production, and we used to get a lot from eating more beef liver and things like that. So our more modern diet is maybe a little bit lower in riboflavin than traditionally. So test these things, see where your genes are at, check your inflammation. And you'll know, like if you're a really sensitive person, you may want to use things like peptides. You may want to do things like that to simmer things down, especially if you just react to everything. Because like some people, they're going to get great results from like broccoli seed extract and milk thistle, and taking, this product or that product that combines, let's say, milk thistle and diindolylmethane which is a modification of indole 3-carbinol from cruciferous vegetables, that upregulates NRF2 and helps to balance, these things you can take in certain ratios to balance phase 1 and 2 detoxification pathways in the liver. And that's another point. It's like, it'd be a good idea to figure out before you embark on detoxification, are you currently a pathological detoxifier, which means your phase 1 is more active than your phase 2, or more efficient, let's say. And so if you have a tendency for phase 2 to not be able to keep up with phase 1, then you get an accumulation of these
Right.
activated intermediates, and that's really dangerous. So those people get worse when they try to detoxify. So it's important to figure that out and then sort like, okay, I may have to actually take a few things to calm down phase 2 and other things to raise, excuse me, I meant phase 1, to calm phase 1 down and upregulate phase 2. When I had like full-on chronic fatigue syndrome, I used to notice that on certain afternoons where I was just like, I felt so heavy and so dead, and like I just like I couldn't do a freaking thing. If I ate grapefruit, I would suddenly go, I just instant improvement in and I could start to function again. And I did not know what that was about. I just somehow intuitively gravitated to trying grapefruit as something, and it has naringin, or is it naringin or naringin? Anyway, it's a bioflavonoid. I think it's classified as a flavonoid. And it downregulates some of this cytochrome P450 enzymes, or maybe just one key one, I'm not sure. And so that could potentially resolve a state of pathological detoxification and help to rebalance things just by chilling out an overactive cytochrome P450. And it's not necessarily it's only overactive for the context, because if phase 2 can't keep up, then it's overactive in that context.
Yeah, it's really cool how you can really get personalized. And when you truly do things for what you need, it's so effective because you're dealing with the root as opposed to the pain point. What you talked about, that phase 1 and phase 2, you reminded me of something that we learned in our research, which is in the glutathione pathway, the GST-M1 gene, there is potential to have a copy number variation. You may not even have the gene, right? And we learned something very odd, that people that had both copies that were, supposedly doing well were directly correlated with having autoimmune conditions. And this seemed odd because we would think that these people do a good job, but this is exactly what you're saying. They're hyper detoxers. But where's it going? Right? If there's no exit, right? And that's why we're saying if you're going to get into a detox regimen, you better make sure you're pooping and peeing probably before you start.
Yeah, that's the one thing, is open those drainage pathways.
Yeah. And so what you're saying is right on, and people need to know that you got to be functional. Don't go in blind and say that this pill or this YouTube video and only solve one piece of the puzzle. And the beauty is that it's not that complex if you want to put the pieces together. Like, you've been listening to Brendan for a little bit here, and you've already been told much more than I'm sure you've heard previously. So it's the puzzle pieces are there. Just need to make sure you're doing it well and A to Z, not just one piece or one segment, and then I'm trying to figure out why it didn't work, right? So, so you do still practice, right? You see patients?
Yeah, I don't call them patients because I'm not.
Okay.
But yeah.
So what do you call
them? Actually, I call them members.
Members.
I have a program, so they're a member in the program. I run it through a private membership association.
Okay, very cool.
Yeah.
And so that's awesome, because that's what it should be. If you're coming to your health, it should be an ongoing quarterback as opposed to someone calling you when they broke something, right? Which is kind of what we deal with medical as, is like, I can do whatever I want, and when something breaks, you have to fix it. That's your job. Right? Meanwhile, I'll do whatever I want. So in your work, do you deal with a lot of women?
Yeah.
Okay.
Actually.
Okay, so I wanted to dive into that, because everything we talked about so far, right? And then add on top of that, I'm a woman, right? Meaning that all of the hormonal considerations, which for sure exist in men, but estrogen dominance and toxicity, you touched on the 4 and 16 hydroxy estrogen, right? Yeah. So is what I'm saying even something to consider, that the outcome is much worse for women? Or are you seeing that there's more nuances or more detailed work required? So all I was going to ask was that, is it that existing, call it female hormone conditions like fibromyalgia, endometriosis, PCOS, all this stuff is just being exaggerated in nature, or is it just another layer of problem they have to deal with?
I'm not sure if I understand the question.
Meaning that I am not me, but a woman may be wired for fibromyalgia genetically and based on her habits. And the current reality of now our exposures is that same woman now suffering from a much more aggressive version of fibromyalgia, or is this environmental exposure just causing new problems that they wouldn't have had if they weren't in this environment or this food environment?
Well, I think it's kind of both, if I'm understanding the question. So, I mean,
Okay.
because all these things like fibromyalgia and so forth, did we have these things 50 years ago? Or if
Right.
we have to go back 70? Like, no, I don't even think there was a diagnosis of fibromyalgia in the world. You know what I mean? Like,
Right.
maybe there
Yeah.
was, but it was like really rare.
Yeah.
So what changed? You know, things have been changing gradually over the last 100 years. And there's been an escalation of things. And there's, yeah, the, the uptick in glyphosate usage, for example, major watershed point where it's just dysregulating so much stuff. And so and the female cycle is very sensitive to
Mm.
a lot of different things. And one of the whole classes or categories of toxic substances are xenoestrogens, meaning
Right.
foreign estrogens. So a lot of these things, like phthalates, BPA, um, mercury is a metalloestrogen. It has estrogenic effects. So as these toxins that are estrogenic accumulate, it's just really whacking out female systems. Mycotoxins, so mold toxins, are highly estrogenic. In particular, certain ones. I think
Mm.
it's zearalenone. And so why are we having so much problem with mycotoxins? We've had mycotoxins for eternity, but according to Dr. Dietrich Klingart, I'm not sure. I think this was, he said, he was quoting research that he did with another doctor, where they they exposed mold to EMFs, electromagnetic frequencies. So they had some mold they
Right.
did not expose it to, and some mold that they did expose to that electromagnetic frequency. And the excretion of mycotoxins went up like 600-fold or something,
Oh.
and the toxicity of the particular mycotoxins went up. Like there was some change in the molecules that made it more toxic. So we have an exponentially higher exposure to toxicity from molds, apparently from EMFs. So that's just in the last few decades that we've had this massive avalanche of EMF exposure. This keeps intensifying. And the explanation, or the theory behind this, is that these organisms perceive, like, they can feel these frequencies and they perceive it as attack. And
Mm.
so they just defend more. Because
Mm.
that's what mycotoxins are about. They're just defending their territory.
Right.
The most famous mycotoxin in the world is the penicillin.
Hmm.
So penicillin is a mold toxin that kills bacteria, because the mold's like, nope, this is my turf, get out, you're dead. And it's
Yeah.
very effective against bacteria. And so they have a lot of things that are very effective at killing other organisms.
The digestive process isn't just about breaking down food, it's about absorbing nutrients and eliminating waste. This is crucial for maintaining a healthy balance in your body and preventing chronic diseases. Our friends at Biooptimizers have a really powerful enzyme supplement that helps you digest your food better so you can get more out of it. It's called Mazymes. Mazymes takes your unique DNA into account by using the best enzymes active at a variety of pH levels to support your digestion throughout your entire digestive tract. Plus, it has Astrozyme, a blend of highly active systemic enzymes to help improve nutrient absorption and support a healthy gut microbiome. Experience optimal digestion the way your body's meant to. So go to biooptimizers.com, that's BIOPTIMIZERS.com, and use the code DNAGO to get 10% off your order.
When something is that complex, like you're dealing with the hormone issue is the foundational starting point, then there's the other food, environmental exposures, EMF, all this stuff. Where do you start? Do you start with the actual condition, or do you believe that that condition is a sort of, it's a outcome of all of this, and let's start here? Or do you have to do it kind of in tandem?
Well, I like to get the whole picture in view. So I do a super detailed assessment of history, the person's history, their family, history, as well. They're just more in broad strokes for the family. All their symptoms, symptom clusters, look at their old lab tests to figure out what lab test might be next, but and just get that whole picture and start to come up with hypotheses about what the causality is. But ultimately, whatever's going on, there is kind of a general hierarchy, a sequence to go through. So I mentioned that you want to quell neural inflammation. That's kind of in general job number one. And if it's present, because it's just making the person too sensitive to everything. Their body's in this defensive posture, and even benign supplements they can react to. And if they're in a mold environment, like, you have to look at, is there current exposure? That's like another one of the job number ones is there current exposure? You got to get them out of that. So a lot of people have mold exposure and they don't know it. And it's not like you can necessarily always just smell it. Oh, my house stinks. I know I've got mold. It's not that easy.
Yeah.
And then there's a lot of resistance. People have a lot of resistance to even looking. They don't want to entertain that idea. Like, no, I could never move. Well, guess what? You might just die there then, or just really suffer for 20 years and then die. But there's a lot of focus on heavy metals, but that's not necessarily the first thing to go after. So you want to get the major inflammatory influences, and mycotoxins is way up there. And then, as we mentioned, look at the genetic picture. So could there be vulnerabilities that are causing them to be more likely to get dysregulated into oxidative stress and inflammatory pathways as a result of having the mold exposure or other toxins, which could be heavy metals, like I said. But so there's certain pathway. I won't go there right now, but keeping with the sequence, then you want to strengthen the foundations, because the person's energy needs to be adequate in order to detox and for the immune system to function normally, and start to combat the infection that maybe it's not been able to defeat, or sometimes the infection has been actually reasonably well controlled, but their nervous system and their neuro immunology is still hyperreactive to the vestiges, even just fragments. There's this one guy, I think his name's Bruce Patterson, that I've have understood to have found that in Lyme and in COVID, post like long haulers, it's the monocytes, I think, that are carrying around fragments of the organisms that they've destroyed, but they haven't been able to get rid of it. So it's still an antigenic stimulant. It's causing the body to be reactive to this pathogen that's basically maybe gone, or at such a low level. And so so that's where, back to the top, where we're like, hey, maybe use peptides to remodulate the immune system. Then you can start to go after residual toxicities and stuff once things are calmed down. So then, so where was I? With the strengthening the energy, and you want to do that carefully. So you support adrenal function, maybe support thyroid function, support mitochondrial function, but don't push it too hard, because the thing is, these people are typically, if somebody's really messed up, I say these people, but I'm thinking of the population of people with chronic complex illness where, it's chronic fatigue syndrome-ish kind of thing, maybe Lyme, they're not sure, maybe it's mold too. And there's this thing called the cell danger response, or it's more of a concept. We don't know that it is the thing, but it's a really great, well-founded idea. There's a lot of evidence behind it that the body goes into certain stages of responding to a threat. One of them is it transforms mitochondrial function from energy producing to defensive mode. And if you push them, they're just going to do more of that, which is produce more reactive oxygen species.
Right.
They're not going to produce more energy. They're just going to produce more inflammation and oxidative stress. So you don't want to push the mitochondria. You can support them a bit with like antioxidants, certain ones like CoQ10 and lipoic acid and so forth, vitamin C, but don't like throw a bunch of L-carnitine and stuff like that. There's a time for that, but it's probably not if somebody's in cell danger response, which is also going to manifest in things like what they call chronic inflammatory response syndrome. So that's a concept of Dr. Richie Shoemaker. Now, not everybody follows, his model. Some people find fault with it, but it's as far as like how he treats it. But it's a good model for as far as like what's happening. this chronic inflammatory response, and there's mast cell activation syndrome. All of these kind of fit into the same pot. They're just different ways of organizing how you look at it. The bottom line is you have to calm things down, and then you have to support energy in a gentle way so the person can begin to detox. And once things get settled down, then you can do some detox. And again, like you were saying, you've got to open the drainage pathways. So if you look at yourself like a funnel, your poop is coming out at the bottom, and then somewhere up here, you've got the gallbladder, the liver and the gallbladder. You've got to have that bile secretion working well. And so unfortunately, glyphosate and heavy metals are impairing all that. And dysbiosis, that's impairing it. So one of the, after you get, probably the first step in improving drainage and getting the bowels moving is simply to go and try to correct dysbiosis if it's there, because that's just going to keep dysregulating the liver with the lipopolysaccharides. So you've got to deal with it. So that's why, all disease, they say all disease begins in the gut, and you start with the gut. That's largely true, but there are some things that are even higher priority, like trying to calm down the neuroimmune response. Some of this you can do all at the same time, but addressing that dysbiosis so that the emunctories, to use an old-fashioned term, will work and keep moving things out through the gastrointestinal tract and liver. You don't want to burden the kidneys too much. And when there's overflow from the liver, then the kidneys are getting damaged because they're not, they are a detoxification organ, but they're not meant to be the primary one.
Right.
Heavy metals are extremely damaging to the liver, like cadmium, as we mentioned. So, and then once you get that stuff moving, it's good to also get the lymphatic system moving.
Mm-hmm.
So learning some lymphatic self-massage, and there's some machines out there that help with lymphatic drainage. That can be useful, especially if there's a pathogen load, because a lot of those pathogens may be hanging out in the lymphatic system. So as you're killing them, you want to make sure they're getting out of the and moving quickly. So what happens is they get dumped back into the bloodstream from the lymphatics and then go to the liver. You can't have a congested liver. So you have to have that working before you work on lymphatic drainage. Once you get all of that going, it sounds really complex, but it's just kind of a 1, 2, 3. You just knock it off. Some people can get stuck on one for a while, and some people just can move quickly through. And they can be like in 0 to 60, all the way in top gear in a week or two. So it just depends on the individual. And then so how do you get this stuff out? Well, there's different things you can use, as I mentioned, to balance phase 1 and 2 and to upregulate, let's say, glutathione, production and conjugation. By the way, on the topic of glutathione, is really important. There's too much emphasis on just supplying glutathione.
Right.
The thing is, if you can't recycle it, oxidized glutathione is an oxidant, and it combines with oxygen to produce superoxide, and that is one of the key drivers of inflammatory stress. There's this whole cycle, this whole pathway where EMFs, glyphosate indirectly via NF kappa beta, so I think certain heavy metals, et cetera, IL-6 and interleukin 6, which gets stimulated by COVID, among other things, and infections. All these things are causing the body to go into an defensive attack mode, where it takes NADPH oxidase, NADPH oxidase, easy for me to say. Let's call it NOx. So the NOx enzyme is taking NADPH and oxygen, is creating superoxide, because it's going to use that to shoot things. It's going to go crazy, come out guns blazing, shooting at perceived pathogens or pathogens. And so we have this upregulation of superoxide, which can be caused by something that's not even a pathogen, like EMFs. Right. So this is another dysregulatory influence of EMFs. But so NADPH is getting routed from, instead of participating in regenerating and recycling glutathione, it's now creating superoxide, and then superoxide is supposed to be controlled by superoxide dismutase enzymes. So there's another place to look at your genes, see if that's an issue. Plus, look at your manganese. You need your manganese for superoxide dismutase to work. And then if it's not, so what superoxide dismutase is supposed to do is turn superoxide into hydrogen peroxide. And then the peroxidase enzymes, like glutathione peroxidase, like the thioredoxins, and like catalase, they can then take the hydrogen peroxide to water and oxygen. So that's how things work for us to control the oxidative in the oxidation, the oxidants that we're producing intentionally. The body's intentionally producing oxidants to go after an invader or perceived invader. But these things can get dysregulated. You can have deficiencies of the cofactors like selenium, which is a cofactor for the peroxidases, and copper and manganese, which are cofactors for two versions of the catalase enzyme. And then you have, so here's what happens. So if superoxide is getting produced in excess, it's not getting shunted off into hydrogen peroxide and then water and oxygen. Then through a variety of steps, there's a few steps, it goes and combines with nitric oxide. So you have superoxide combining with nitric oxide to produce peroxynitrite.
Right.
So that's the peroxynitrite cycle. And that's being implicated in more and more diseases. So it's like a new frontier. Like, oh my God, we see peroxynitrite upregulated in all of these conditions. So that's another thing that that's being discovered. And it's and how did I get on that topic? I guess I was basically saying that that there's all these things that can be happening that are just distracting the body's resources from detox.
Yeah.
Because now you're using up the NADPH. There's a guy that calls it the NADPH steal. Bob Miller calls it NADPH steal because it's stealing the NADPH resources over to that wartime use instead of peacetime. Right. Peacetime use would be anti-aging, detoxification, water skiing, whatever you want to do with your energy. So,
so
where was I?
Yeah, I mean, everything you've laid out, this is stuff where people wanted to know the actionable side of it, meaning that these are all bits and pieces that you hear, right, in different conversations, but we don't know what to do with it, right? Yeah, I'm really honored that you gave us this time because you made it so clear, so concise, right? And you've condensed.
I don't know about concise, but
well, concise meaning in the way that the number of things that you just laid out, we could have just talked about one portion, like like you said, CompT, like just that. But you gave us the whole map. And if anyone replay this, listen to it 3, 4, 5 times, because you've been given the map. Here's exactly what you need to do, and start working on it bit by bit by bit. Start working out in the order you were told, so you don't cause yourself a plug up or clog up. Do it in the right fashion. But this is it, man. It's obviously, we know that food is a concern. We know that from glyphosate to everything else that's being ingested, not only through our food, but through our skin and through what we breathe, there's no doubt that chronic disease in general, it's a part of life now where it used to be an anomaly, right? Like you said, fibromyalgia wasn't a thing 7 years ago. It's now a given, some kind of hormonal disruption and hormonal disease. So long story short is I want to thank you, because this was mind-blowing for me, and I hope everybody enjoyed it as much, because you were able to really in an actionable way, I should say, deliver. Here's exactly what you do, right? Here's all of it. Here's what your members have been benefiting from, and we just got a sneak peek into. And I should ask you that maybe before we go, how do people work with you if they want to?
Well, a good way to connect would be to actually download the free report.
Right.
So, and I think I'm changing the name from How to Stop Agricultural Toxicants from Killing You, Why Eating Organic is Not Enough, and How to Biohack Your DNA to Protect Yourself, or something long like that. To just, I think I'm simplifying it to Biohack Your Detox.
Right.
So look for that, one of those, either the real long title or the short title, and download that. So that's going to present what I've just discussed in more detail and in a more organized fashion. And it's each topic is done pretty concisely, but there's a lot of detail there, and then it comes into some pretty detailed steps people can take. And then also, so there'll be links in that to where they can go to schedule a free conversation. I actually have meant to embed my scheduling form on a particular, they could go to bioindividualblueprint.com.
Okay.
It's not its own website right now, but it will be in a moment. So, and it does forward to a page that's functional. So bioindividualblueprint.com. Also, check out the Eat for Earth event. You'll get on my newsletter there. Go.eatforearth.org if you want to sign up for a free viewing period of those Eat for Earth interviews that we talked about.
Right.
And what else? Yeah, and I want to say that, I love the DNA company's concept of storyboarding.
Right.
And because that's essentially what I've been trying to do, is like there's these different stories, there's these cycles. Each cycle is a story. It's this thing that could be happening as a result of these various influences. And you kind of got to map all these things, figure out, you don't necessarily have to map them all, but it's a good idea to look at your genes and look at your symptoms and figure out, okay, it looks like maybe the peroxynitrite cycle is happening. And there's, you can look at certain tests where look if there's DNA damage evident in certain metabolites that show up in urine, and that would be potentially caused by peroxynitrite because it's and the carbonate radical, which comes off of that, which is off of that cycle, which are damaging the DNA. But yeah, so but generally I work with people as both in one-on-one and in group context in a group program, and so those are some options we can talk about if one of the listeners wants to.
Yeah, that's amazing. We're going to share the link so people can download that guide that you produced. And I've signed up for the newsletter myself because I'm anxious to learn more. I suggest everybody does. It's a blessing that you have access to information like this when we're all struggling. The reason you're here today is to figure out the why, like what's going on. Well, here it is. You have access to it. Thank you again, Brendan. This was incredible. It was, all the answers that I personally was looking for. You sort of laid out and more. So thank you again for your time.
Oh, my pleasure. Thanks so much for having me.